I would recommend you guys follow along on page 233 as well, as we're talking about synthesis and decomposition. And I'm going to explain those pictures there right away. You don't necessarily need to draw them. They are in the book. What's up on the screen is my version of what's on page 233. What do you think? What does synthesis mean, or synthesize? No, but what does it mean? Like in everyday kind of. But what does that mean? Fake? If you synthesize something, what does that mean?
Mix it up.
Well, okay. Let's talk about oil. What does synthetic oil mean? Like there's synthetic oil, and then there's, well, I guess non-synthetic. It's good. That's all you know. It's good.
Combination.
A combination of what?
Small particles.
Okay. So synthesize kind of means to like put together. And what does decomposition mean? Is that what you said, Nathan? Okay, sorry, man. What does decomposition mean?
Involves breaking apart.
Oh, you're just reading from something.
No, I'm guessing.
Involves breaking apart?
Yeah. Or
Okay, good. It says here on page 233, imagine that you're baking some cookies at home and have decided to modify a recipe for oatmeal raisin cookies because you don't have any raisins. You know that there are patterns in the way that certain ingredients go together, so you make a new recipe by substituting dried cranberries for raisins and cornmeal for oatmeal, or maybe you just throw chocolate chips in instead of the raisins like we're all going to, right? Just as a cook knows how ingredients will work together in a recipe, so a chemist knows that elements and compounds undergo particular types of chemical reactions. You know that elements can be classified into different chemical families. All members of a chemical family react in a similar way. For example, alkali metals behave in similar ways in chemical reactions. Compounds can also be classified as ionic or molecular and have definite patterns of chemical bonds. Chemists use these patterns to classify groups of chemical changes. Most chemical reactions can be grouped into 4 categories: synthesis and decomposition, and then single displacement and double displacement, which is something that we're going to look at probably next week when I return. Knowledge of these types of reactions is useful for 2 reasons. Firstly, we can better understand experimental observations of the behavior of substances and chemical changes. Secondly, we can predict the products of unknown reactions. Look at the reactions represented in Figure 2. So Figure 2 is that purple and green balls there, which is kind of what I've got up on the screen. Which reaction involves elements as reactants? Which reaction involves elements as reactants? Which reaction involves compounds as reactants? Recognizing the types of reactions is key to identifying the reaction type. First, we'll look at 2 of the reaction types: synthesis and decomposition. So, the synthesis reaction, you got a purple thing there, purple ball, plus a green ball, and you mix them together and you get
a big purple ball.
a big purple and green ball. It's purple with green polka dots. Could it also be green with purple polka dots?
Yeah.
Sure. They just had to pick one, right? Maybe there's twice as much purple as there is green. And then in the second one, decomposition, the purple and green ball is what's happened there? They separate. They pull them apart. Okay? That's kind of what I've shown up here on the screen. I use blue, I guess. I got a blue ball plus a green ball. And then you get like a combination, kind of chocolate chip cookies. Here the chocolate chip cookies pulled apart. So this synthesis really just means, like in everyday sort of language. Oh, hello. Moving on to page 234. So what is a synthesis reaction? Synthesis reactions involve the combination of smaller atoms and their molecules into larger molecules. Ashton, you can write that down now.
Peanut butter.
Oh, here we go.
What?
Okay. So synthesis reactions involve the combination of smaller atoms or molecules into larger ones. These reactions are called combination reactions as well. Often the reactants are elements that combine chemically to form compounds. Synthesis reactions have the following general formula. So if you've got A plus B, are you ever going to see the formula A plus B? No, A just represents some chemical, B represents another one, and when you add them together, you get AB. Okay, it's just general format. Okay? Basically, you could sort of go with, if there's more things on the left and less things on the right, then it's a, what kind of reaction? Synthesis. Okay, if there's more things on the left and less things on the right, then you've got a synthesis reaction. Okay? And examples are hydrogen plus oxygen gives you water. Hydrogen plus oxygen gives you water. If you burn hydrogen gas, you get energy. It combines with oxygen in the air, and you get plain old water. People are trying to make cars and vehicles that run on hydrogen. How come?
Cheap.
What's
They can make water.
what's the byproduct? What's coming out the exhaust pipe of a hydrogen-powered car? Plain old water, which really isn't that dangerous, right? Plain old water vapor. Not a problem at all, right? Much safer than carbon monoxide and the other things that are coming out your tailpipe.
And also, hydrogen tanks, if they rupture, they just produce like a 10-foot long jet instead of just
Wow.
a massive pipe.
Yeah. If it's lit, though, hydrogen gas is kind of explosive. So that's kind of the downside. Pardon me? I think it can be made stable as a solid, but when it gets old, like TNT, when it gets old and starts to break down, and it starts to form into a liquid, it becomes unstable. I believe. Don't quote me on that. And don't try and blow something up. Okay, so there's just an example, right? There's a couple more there as well. Let's flip down to decomposition reactions. Decomposition reactions involve the splitting of a large molecule into elements or smaller molecules. Decomposition reactions have the following general formula. So it's AB gives you A plus B. In other words, if you've got one thing, less things on the left and more on the right, then that's quite likely an example of decomposition, breaking down. Okay? If you see a binary compound, blah, 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 blah. Okay, I'll give you the opposite. If hydrogen plus oxygen gives you water is the synthesis, then that should mean that water can be broken down into hydrogen and oxygen. Does anyone know if that's possible? Can you take plain old water and break it down into hydrogen gas and oxygen gas, actually?
Yes.
You should pay attention so that you know this, so you know how to do this stuff later. Water is hydrogen oxygen, but is there some way to break it down into those two parts? And the answer is yes, we can do that right here. In fact, if I have the equipment out, I can set it up for you. We'll get that set up next week. It's called electrolysis of water. You might have seen it in elementary school. You got two test tubes with two electrodes poking up like this kind of thing, and they run a battery through them. Has to be a little bit of salt in the water so that it'll conduct electricity. And the electricity will actually separate the oxygen and the hydrogen. You can light the oxygen and the flame will burn brightly. You can light the hydrogen and what will happen? It'll go be a giant explosion and it'll burn all my eyebrows off. Or it'll just go. One of those two things. Do you want me to lose my eyebrows? It'll be more just up. Give me 2 seconds. I will get that set up for you next week. I got to get some equipment out to sort of do it, but I can definitely show it to you. It's not that big of a deal. Okay. Cole, didn't I say give me a few minutes?
What?
I said give me a few minutes. Let me finish it. Oh no, just give me another minute or two. And, yeah. Okay. If you look, Nathan was probably asking about nitroglycerin because it's there in Figure 5. Those red sticks there. Nitroglycerin, the active chemical in dynamite, is an unstable compound. Its decomposition reaction is violent and results in the formation of carbon dioxide, water vapor, and molecular nitrogen and oxygen. And it makes things go boom. Right? But you have to add energy to it. You add a little bit of energy, you get more energy, and it's a decomposition reaction. Okay? All I need you to know is how to classify it as an S or a D. I'm going to give you a worksheet here. It's not going to be that hard. Okay? No, we should watch. Yeah, you go to the bathroom. We'll watch the cool videos.